Okay, just going to talk you through question 3 in the homework. This is a difficult question which appeared on an A-level paper a few years ago. What makes this question more difficult and different to examples we've seen before is that the equilibrium number of moles has not been given, and you need to calculate that from some titration data. Okay, so here goes. So first of all, the equilibrium. We got ethanoic acid, ethanol in equilibrium with ethyl, ethanoate and water. We've been given our initial or our starting number of moles of ethanoic acid and ethanol. Okay, and we're told it reaches equilibrium at 20 degrees Celsius. We're then told it is diluted to 250 cubic centimetres. So this becomes important later on when we're calculating our volumes and concentrations. And then we're told a 10 cubic centimetre sample of this equilibrium mixture is titrated with sodium hydroxide, which was in a burette. We sometimes call this, when you take a small sample out of your big solution, an aliquot. So that's a term you should become familiar with. And then this aliquot, or 10 cubic centimetre sample, reacted with 3.2 cubic centimetres of 0.2 mole per decimetre cubed sodium hydroxide solution. So therefore you've got a volume and a concentration. You can calculate the number of moles of sodium hydroxide. And from that number of moles you can calculate the number of moles of ethanoic acid at equilibrium. We need to calculate the Kc for this reaction. Okay, so first things first, draw your table. So you've got your acid, your alcohol, ester and water. Your initial number of moles are 0.0800, your alcohol is 0.120, ester and water. Okay, you have to give your answer to an appropriate number of significant figures. All the information was given to 3 sig fig. Now there's no equilibrium moles here to help us decide what the change is, so we need to use the titration data. So calculate the number of moles of sodium hydroxide reacted with the aliquot, which is at equilibrium. So take your volume, divide that by 1,000 to convert to decimeters cubed, multiply it by your concentration, and you get a number of moles of sodium hydroxide. Now the stoichiometry of this reaction is that sodium hydroxide to ethanoic acid is 1:1. So therefore the moles of sodium hydroxide will equal the moles of ethanoic acid in 10 cubic centimetres. But we need to know how many moles of ethanoic acid were at equilibrium, and that was in the 250 cubic centimetres sample. So we take out our number of moles of ethanoic acid, we just calculated, and we divide it by 10 and times by 250 to scale up to the number of moles in 250 cubic centimetres. And then once you know that, you can put that value in as your equilibrium number of moles of carboxylic acid or ethanoic acid. So you can put that there in the table. Once you've got that value there, the difference between the two values will be the change. And then we go back to our reaction stoichiometry, which is 1:1 to 1:1. So therefore, the change in the number of moles of acid will be the same as the change in the number of moles of alcohol, which will be the same as the change in the number of moles of ester, and water. Okay, and so therefore calculating your equilibrium moles shouldn't be too difficult from that information. Then finally we need to convert our number of moles to a concentration by dividing by 250 cubic centimetres or 0.25 decimeters cubed. So I've just done this because it's easier to do. And then once you've got your concentrations, you can calculate your Kc value, remembering that Kc is equal to the concentration of the products divided by the concentration of the reactants. Okay, I hope this has been useful.